we are given 4 sets of compounds. Each set contains 2 species. We are given a weaker base and a stronger base. We have to explain why one species is weaker than the other. In 1, we are given hydroxylamine and ammonia. OH group is electron attracting by inductive effect. So this decreases the electron density on nitrogen. The electron density on ammonia is more than on hydroxylamine, and therefore the base strength is less for hydroxylamine. In the second set, we are given CCl3 minus and CF3 minus. Both are anions and both are stabilized. But we would expect CF3 minus to be more stabilized because fluorine is more electronegative. It exerts a strong inductive effect. So the charge dispersal should be greater in CF3 minus. But we actually find CCl3 minus is a weaker base. That is, CCl3 minus is more stabilized than CF3 minus. This is because we have resonance operating in CCl3 minus. Resonance stabilization is due to 3 possible resonance structures we are able to write. Each involves a pi bond between the p orbital of carbon and a d orbital of chlorine. Since fluorine cannot use the d orbital, there is no such possibility in CF3 minus. But chlorine can make use of d orbitals, and we are able to draw 3 canonical structures where the charge can be delocalized. This resonance stabilization is more effective than the stabilization by inductive effect, which makes CCl3 minus a more stable species and hence a weaker base. In the third, we are given hydroxide and the amide NH2 minus. Oxygen and nitrogen both belong to the same period in the periodic table. In general, for a given period, if there are more lone pairs of electrons, the charge is more spread out. In hydroxide, oxygen has 3 lone pairs, but in amide, nitrogen has only 2 lone pairs. The charge is more spread out in OH minus, and therefore hydroxide is a more stable species and hence weaker base. In the next set, we have iodide and fluoride. Both belong to the same group in the periodic table. Fluorine is a smaller species and iodine is larger. In a larger anion, the charge is more spread out, and therefore in iodide there is a greater degree of delocalization. Iodide is more stable and therefore less basic. We have guanidine, which is a very strong base in aqueous solutions compared to the amines. Amines are not as basic as guanidine. It's an example of a very strong base. This is because if we consider the conjugate acid, that is the protonated species of guanidine, we have 3 canonical structures where the charge can be effectively delocalized among the 3 nitrogen atoms. That is, the conjugate acid is very much stabilized and becomes very weak. If the conjugate acid is very weak, the base must be very strong, and hence guanidine is a very strong base.